Okay, so we will be covering in the book section 5.4. This is going to be a little longer, short video. 5.4, section 5.4. Let me talk about triangles really quickly. So in 5.4, section 5.4, this is the level 2 drilling practice. You'll see this a lot. You'll see two triangles. And what they'll do is they'll take this one picture and they'll try to make different types of problems out of this one picture. So we could find a missing side, or we could find a missing side. I know. So we'll find a missing side of two triangles. If they give you, I think they need to give you three numbers. So they'll give you a B hash. That was called. It's not apostrophe. Brain freeze. So they'll give you this side, and then they'll ask you to find this side. So problems like number 36, 37, 38, they're wanting you to use proportion to solve this because they're giving you three sides. When they give you two sides, they want you to solve this using Pythagorean Theorem, and that's what we're going to cover in this video. Pythagorean Theorem, to make sure you know when to square and when you're going to subtract or add. Alright, so let's do number 42 since it's already down here. Alright, 42 is one triangle, and it has two missing sides, so that means Pythagorean Theorem would have to find this missing side. I'm going to do 42A, and I'm going to do one that's opposite of this. Opposite of this, so we'll have practice with it. So 42A. We're only going to do opposite over adjacent as well. So 42A, opposite over adjacent, so we know exactly what we are doing. So I think I'll draw this triangle to make it a little bit easier to work with. And paper. So box. This is a right angle. This is 5. And this is A, B, C. I'm not an artist. Sorry. So we're looking 42A. The pen is still dying. Alright, so first we have to find this missing side. Again, I have a right triangle that gives me two sides. I find this side. And I have to determine what side am I trying to find in order to do this problem. Remember, Pythagorean Theorem is a squared plus b squared equals c squared. So C is that slant, and then A and B are the legs that touch the box. So I'm going to go ahead and label this A. Let's do A, B, and C. You want opposites, so A, B, and C. So I have A squared. I have B squared. And how did I know that's C squared? C is always a slant, and it's always across from your box. A and B, I normally do opposites or adjacent. Today I'm doing opposites. So B, opposite of B is going to be this number. A, opposite of A is going to be that number. So 5 squared plus 12 squared equals C squared. 5. There's my square. I'll turn it on my notebook. 5, and then there's my square. It's 25. And if you already know this, that's fine. I'm just trying to help with the calculator. 12 squared. It's 144. Equals C squared. 144 plus 25 is 169. Now I have to get rid of this square. To get rid of it, I'm going to square root. So to get rid of a square, you square root. Get rid of the square, you square root. So I'm going to square root both of these sides. In equations, because we have the equal sign, everything is balanced. The clipboard or something to keep. So squares and square root. That leaves me with C. And then I'm going to see if this comes out to be a nice clean number. If it does, I put a nice clean number. If it doesn't, I'm going to keep it at square root for this course. Now once you get into your pre-calculus courses, then yes, you may have to rationalize it or make it a decimal. But we're going to keep it a clean number or under the square root. Okay, so square root for this calculator is second x squared. Second x squared. So x squared squares it, and the opposite of that is right above it, the square root. Clean number. That's really my clean number. It comes out to be an even number. No decimals. So if 169 was not a clean number or perfect square root, then we will leave this as a square root of 169. But it's perfect, so we're going to leave it. So that means this is 13. The direction stated to find the following ratios for the angle A. So for angle A, we want the opposite over adjacent. Opposite over adjacent. So opposite means we want the number that's across or opposite from this angle. So angle A is what we're going from. So opposite of that is 5. Adjacent means it touches the angle, angle A. And the hypotenuse is always that slant. So this is A. What touches A? 13 touches A, but that's not adjacent, that's hypotenuse. So that means 12 has to be my adjacent. Okay, so that's how you work out a Pythagorean Theorem problem and find the size needed. So let me try to find another problem. 46A. Let's get 46A. 46A, same section. I'm going to do 46A. I'm going to look at the difference between that. So let me draw this triangle. Please excuse my art. The best I can. So I had to go to school to be a math teacher. A, C, and B. So I'm on 46A, same section, 46A. Look this up so you don't get any of that old problem. Alright, so now I'm looking at A squared plus B squared equals C squared. Remember, A is going to be here, B is going to be here, C is going to be here. You don't have to rewrite the formula every time, but I'm doing this for our video. Let me pause to make sure you're good with why I chose those numbers. So A is there, B is across from there, C is across from there. So A squared, I don't have a number for that. I'm trying to find. B squared is 1 squared. C squared is the square root of 37 squared. Let's just clean this up. a squared plus 1 equals, ooh, look at that, it looks a little weird. But what we just learned? Good, we just learned a square root, and a square. It cancel each other out, good. So it just comes out. Good. Gotta solve this equation because my numbers are on different sides. So last problem, all my numbers are on the left. This problem, I have a number on the left and the right. So I want to separate my numbers in letters. I gotta separate that a squared and that 1. And I did that. So now we're still left with a square. We did it up top, but we're still left with a square. So that's we got to square root. Let's see if this comes out to be a clean number. If it does, I keep it. If not, it's going to stay just like this. The square root. Square root of 36. If you already know, that's fine. Not. Work it out here. So that's 6. So we have to find our opposite over adjacent now. So now that we know that a is equal to 6, and you can go back and check that. Remember, it's an equation, so you can balance it out and make sure your numbers are correct. So opposite over adjacent. I'm going from a. Opposite of a is 6. And then what is touching a? I have 1 touching a, and I have square root of 37 touching a. Remember, one of these is a hypotenuse. So the adjacent touches a, and it's not a hypotenuse. So that means this is going to be my adjacent 1. Now, you cannot reduce this because the answer says keep it as a ratio. This is keep as a ratio, so you gotta keep it as a ratio. You can't change it to 6, even though we know 6, but I want is 6. We can't change it to 6 because it is a ratio. Alright, I am in 6.2 with perimeter. 6.2 with perimeter. Chance to pause and go to that section. And this section of module 3 is a little challenging, so I want to go over some problems. When you see them, you're going to freak out because they don't really do a great job of teaching you how to do this. So we're going to work with these together. Okay? Alright, here we go. Alright, so this says find the distance around the exterior of the figures in these problems around the approximate answers to 1 decimal place. Alright, so here I have what? Excuse me, it's supposed to be a circle. Sorry about that, y'all. It's supposed to be a circle, but it's a half of a circle. So to find this distance, I want to take half of the circle, or find the circumference, and divide it by 2, or multiply by 1/2, and then we're going to have to do one more thing. Alright, so let's do step by step. So this is the circumference. So circumference is 2 pi r. This is on, sorry, I don't have pages anymore. Page 258, you still have an older book. But this is in section 6.2. So it tells us the formula is 2 pi r, or diameter times pi. I did have a formula sheet somewhere. Formula sheets are in your midterm folder if you want to go pull that out real quick. So this is for a whole entire circle, but we don't have a whole entire circle. So we're going to multiply this times 1/2 or divide by 2. So again, why are we dividing this by 2? Whole circumference means we have the outside of the circle, but we don't have a whole circle, we have half a circle. And so circumference only covers this part. Circumference only covers this part. I have to add in this part on my diameter because now it's a part of the outside of my circle. So if I have a whole circle, I don't include it inside because it's not a part of the edge of the circle. But because it's cut in half, you can't just leave it open. You have to close it. So circles, it encloses itself. But if you cut the circle any kind of way, you have to enclose it. You have to add that part to enclose it. Close it up. Just can't keep it open. Anything else will fly in and go in. You don't want that. You want to close it off. So that's why we're adding diameter. Okay, so let's go through this. So our diameter is 100. So we're going to put this in the calculator. Now I do suggest that you put pi in the calculator and not 3.14. It will give you an incorrect answer if you're not careful. So 100 pi. Enter. Enter. And we're dividing this by 2. So this is 157.079. Notice I'm not rounding, because if you round the last part of your problem, 157.079 plus 100. You want to round at the very, very end. Or if you don't want to even write that down, you just want to keep going, plus 100. Now you can round this. And you can't round at this point because we still have to add that 100. But now you can round this because we're doing it on the calculator. It weren't done on paper, but we're doing it on the calculator. So this would be 257.08 or 257.1. I think it says round to 1 decimal place. So we're going to round to 1 decimal place. 257.1. And don't forget your unit. This was centimeters in the book. So I'm going to keep it in centimeters. Alright, review that as many times as needed. That was a toughie. So this was half. We cut it in half. If it was a quarter, then we would make it 1/4. And then add our sides as we need it. Okay? So 41, let's calculate where we're going to start. 41 is a little different. Students see this, same section. Students see this problem and start panicking as well. So let's look at number 41 in the book. Break it up and I'm going to draw it again. So it looks like this. It looks like this. So I'm going to draw that. So this is going to be 120 feet. And then this is going to be 50 feet. Looks so crazy, huh? Alright, so let's break this down. So what do we see? So this part is supposed to be straight, and it looks like a rectangle. So I'm going to draw that. That looks like a rectangle, right? So when I see the distance around this, I look at this as length times width times width, or length, width, length, width. So this is actually the length of a rectangle, length and length. I'm not including the width because it's not on the outside. Now, if we were doing area, then we would need to include the length and width. But we're not including area. area is on the inside, perimeter is on the outside. So I'm going to distance to the outside. So this is L and this is L. So we got this stuff done. This right here are my curves. It looks like a circle, right? So again, I need to figure out what this curve is, and I have a diameter. Look at that. I have a diameter. So I'm going to use that same formula we used earlier, because it actually looks like that too. And we have two of them. So we have this one and we have that one. If you can see that that's actually a whole circle, then you can just put it together as d times pi. But if you can't, do part by part. So this part was a L's. That half was this, that half was that. And 2 halves equal a whole. So you can skip that if you like, but I like to do part by part because it just makes more sense to me. But how do you want to do it? So let's start putting these numbers in. So the length, sorry, my arc is off. So 120 and 120, okay? And then we have our diameter times pi divided by 2 plus diameter times pi divided by 2. Diameter times pi divided by 2. Diameter times pi divided by 2. These are numbers. I can do that mentally. That's 240. Okay. These are the ones I need to figure out what those are and just add it twice. So 50 times pi divided by 2. 50 times pi divided by 2. 78.5398. 78.5398 plus 78.5398. Again, I don't round, because in the middle of your problem you don't want to round and then round your final answer. So you want to take as many digits as you can. I always take 3 to 4 digits out. That's just my go-to. And then I start adding. So there's that 78.5. Actually, I'm just going to clear this and just add this all together. 240 plus 78.5398 plus 78.5398. So what the calculator is going to do is going to round your answer for you down here. So that's why we want to round it, take a whole bunch of numbers, because the calculator is going to round automatically because that's what it wants to do. So it's going to round that number down there, but it's not going to affect my final answer. It's going to round on its own down here, but I need my numbers. So this is 397.1, and this is going to be feet. Again, I believe, yes, feet. Okay? So let me run back over this problem again. This is a complex type problem where you have a bunch of shapes in one. And they can do this with a whole bunch of problems. They can do this with a triangle and a square. They can do this with half of this problem. They have a rectangle, and then they can do this with a whole bunch of problems. So you just have to be able to figure out what 2 or 3 shapes are they connected together and add them yourself. And put the answers together, I'll say that. Add the parts together. So here was a rectangle in the center. We didn't use the width because we're only looking at the outside. So the length, circumference. And it wasn't a whole entire circle we were looking at part by part. It was half of a circle. That's why we did the divide by 2 and the divide by 2. Again, if you could see that those 2 parts will make a whole entire circle, you could have just done length plus pi times d times pi. And it would have come out to be the same thing. Okay?